Calculate the right endpoints approximation r sub 4 and r sub 6 for f of x equals x squared on the interval 1, 3. In this case, a equals 1 and b equals 3. With the notation r sub 4, we're using n equals 4, so we would need to cut this interval into 4 subintervals. Each of these has a width of 3 minus 1 over n, where n equals 4, and this is 2 over 4, or 1/2. The first endpoint is x equals 1, and the next one is therefore 1.5, because the width is 1 over 2. The next endpoint is 2, the next one is 2.5, and the last one is therefore 3. The width of each of these subintervals is again 1/2. But we're using the right endpoints. There are 4 rectangles. The first rectangle has a width of 1/2, and the height with the corresponding x equals 1.5, the right endpoint of the first subinterval. We would plug this into the function to find the height. The height in this case is therefore 1.5 squared. And then we move on to the next rectangle with the width of 1/2. The height is now 2 squared. The next rectangle has the width of 1/2 and the height is 2.5 squared. And the last rectangle had the width of 1/2 and the height of 3 squared. Usually, since they have the same width, we simply factor out the width 1/2 and we add the heights only. The height is 1.5 squared plus 2 squared plus 2.5 squared plus 3 squared. And again, we're using the right endpoints. The graph is y equals x squared. And for each of the right endpoints, we would go to the right endpoints and we would draw the height of the rectangle, and we form the rectangle. So again, for each of the subinterval, we go to the right endpoints and draw the height. The height is the value of the function. It is a functional value. The value of the function tells us how high the graph goes. And then we form the rectangle using that height. We should end up with 4 rectangles in this case. We would then evaluate this sum to obtain approximately 10.75, and this should give us an overestimate here. With the same function over the same interval from 1 to 3, but this time we would need to use 6 rectangles, so we would divide this subinterval into 6. The width of each of these subinterval delta x is therefore 3 minus 1 over n is 6 now. This is 2 over 6, or 1 over 3. The right endpoints are, we take 1, which is 3 over 3, and add 1/3 to it to get 4 over 3. Add another 1/3 to get 5 over 3. Another 1/3 to get 6 over 3. Another 1/3 to get 7 over 3. Another 1/3 to get 8 over 3. And lastly, 9 over 3 is 3. 6 over 3 is 2. Having these right endpoints, we can now approximate r sub 6. Since all of them have the same width, we would factor out 1/3 at the width and we add the height. The height is 4 over 3 squared. That is the height of the first rectangle using the right endpoint. We take the right endpoint and we evaluate it using the function to get the height of the rectangle using the right endpoints. The next height is 5 over 3 squared. The next height is 6 over 3 squared, or 2 squared. The next height is 7 over 3 squared. The next height is 8 over 3 squared. And the last height is 3 squared. We should have 1, 2, 3, 4, 5, 6 terms because we approximate R sub 6 using the right endpoints here. Plug this into a calculator. We will see that this is approximately 10.0370. Since we're using more rectangles, this will be a better estimate than R sub 4.